Okay, the next thing we're going to talk about in Chapter 5, actually the last thing we're going to talk about, is triangle inequalities. So we're still dealing with writing inequality statements, like less thans and greater thans, of two triangles. Remember yesterday, or excuse me, last section, we dealt with triangle inequality theorems, third sides, and a couple other ideas. Today we're going to be bringing in indirect proofs. And you remember an indirect proof is proving something indirectly. Pretty basic, right? Again, what that means is you're proving something else false. Like I would prove that gravity is false by proving that something doesn't come down once it's thrown up. That would be an indirect proof. I would prove that water boils, or water doesn't boil at 100 degrees Celsius by proving that it, doesn't freeze at 0 degrees Celsius, and so on and so forth. What I want you to do is I want you to look at these three pictures. And what I want you to do is I want you to look at triangle ABC in each picture. Now you might be saying, well, it's a different triangle every time. Yes, you're right. It is a different triangle, but certain elements stay the same. And what I want you to first notice is how AB does not change. And that's a horrible rendition of AB. Let's try this. AB doesn't change. In all three images, AB is the same size. And the reason AB is the same size is because AB represents the width of the gate. The gate didn't change. What you'll notice is the door swung open. My other comment is this. Did the door's size change, or did AC change? And the answer is no. The width of the door, or the size of the door, stayed the exact same the entire time. Meaning AC did not change once, even though the door swung open. So the width of the gate stayed the same, and the width of the door stayed the same, but you will notice that the distance from the door to the post, or I guess you could say the amount that the door is open, that changed significantly. It changed each time. AB didn't change, AC didn't change, but BC changed 3 times. And that kind of leads us into our triangle theorem, or our triangle hinge theorem. And what the hinge theorem says is if two sides of one triangle are congruent to two sides of another triangle, and the included angle, meaning the angle in between them, is larger than the included angle of the second, then the third side is larger than the third side. Now we could have just applied what we knew last section here and said 88 is greater than 35, so this segment is greater than this segment. It's the exact same thing. They're just bringing you into the idea of congruent triangles, which is something that we're going to deal with moving forward in geometry. Conversely, if you have two triangles, or two sides of one are congruent to two sides of the other, if you have one side greater than the other, greater than the third side, if the third side of one triangle is greater than the third side of the other, then the angle opposite is going to be greater than the other angle. And again, here we're going from an angle to a third side. Here we're going from a third side to the angles. And that's what the converse actually means. It's flip it around. So if you have two sides of one triangle congruent to two sides of the other, and the included angle is greater than the included angle of the second triangle, then the opposite side is bigger than the other opposite side. The other way we can say it is if two sides of one triangle are congruent to two sides of another triangle, and the third side of one is larger than the third side of another, then the included angle, or the angle opposite, the larger side, is greater than the other angle. See how they wrote angle C is greater than angle F. Here we could write an inequality that says WX is greater than ST based on their inequality or based on their comment. Now, that's, not too difficult. But the way that this applies is in this real life scenario. Here we have example 1. And this image, by the way, is an image of, or it's an aerial shot of Mackinac Island. The red line being a trail that you can bike on Mackinac Island that will take you through an old battlefield. 2 groups leave their camp and bike in opposite directions. Here's their camp, and we can see Group A went this direction. Actually, that's not true. Group A went in this direction, and Group B went in this direction. Now we can see they both went 2 miles, and then they changed directions and traveled another 1.2 miles. So they both traveled 3.2 miles. 2 miles plus 1.2, 2 miles plus 1.2. Both of them traveled 3.2 miles. Group A starts due east, okay, east, and then turned left or north 45 degrees, and then went another 1.2 miles. Group B went west 2 miles, and then turned south 30 degrees. They made a 30-degree turn left. Okay, north, south. Now, which group is farther from the original camp? Meaning, is Group B farther from camp, or is Group A farther from camp? Let's say their bikes broke down and they had to hike back. You would want to know which one is farther. And the way we can do that is by first just identifying what we have congruent. We know that both groups traveled 2 miles to start. Then we know that they traveled another 1.2 miles. So that's congruent also. But what we have is we have one group turned 45 degrees and one group turned 30 degrees. Now, something that is very, very simple that you might be just overlooking is that 45 is greater than 30. That makes sense. 45 is a larger number, so it's greater than. But what does that tell us about these distances right here? What does that tell us about that? You should be telling yourself, based on the Hinge Theorem, or based on the Hinge Theorem, if one angle is larger than another angle, then the side is larger than the other side. So here we have 2 angles. We have 45 and 30. But because 45 is greater than 30, Group A, not Grop A, excuse me, I hate English. Have to write things proper. Group A is a further distance than Group B, meaning this distance is larger than this distance. Now, 15 degrees might not be a whole lot, especially since they only travel 2 miles and 1.2 miles. But if you were talking about 15 degrees over 100 miles, 15 degrees might be 15 miles. You never know. But based on the Hinge Theorem here, Group A is farther than Group B, or is farther from the base camp anyway, even though they both traveled the same distance. The angles that they turned at determined how far away they ended up going. Group B ended up actually coming back toward the camp a little bit. Group A didn't come back to the camp nearly as much, so they are a further distance away. That concept of the Hinge Theorem is really the only new idea that you're going to talk, or that we're going to look at in this section. Understanding that if 2 parts of one triangle are congruent to 2 parts of another triangle, then you're looking at the included parts, which is the angles. If one angle is bigger than another angle, then you know the sides are bigger than. Or if they give you the sides, then you know that the angles are larger. So just taking that concept, let's take a look at your homework tonight.